This is going to be the first in a series of review videos for skills on factoring. We're going to start off with factoring the GCF from a polynomial. Now, most of us already know the GCF is the greatest common factor, but as a reminder, and remember, a lot of us forget that when it says greatest common factor, that's not just the name of it, it needs to be the largest number that can divide evenly into all of your terms. So a quick reminder of how to find that. Most of us, off the top of our head, can look at them and figure it out pretty easy. But just in case, let's look at a couple. Let's say we have 30 and 45. How do I find the GCF? A lot of us right now are saying, oh, well, Ms. Finn, we already know the GCF. You're right, you might. But just in case, 30, this is how I do this. I always start at 1. 1 times 30, 2 times 15, 3 times 10, and then I think 4. This 4 going to 30. Well, 4 into 28 is 7. So no, it's not going to go. It's going to be a decimal. I'm not going to use it. 5 gives me 6, and the next number will be 6. But since I already have a 6 in my list, that's it. I've got all my factors. 45. 1 and 45. 2 isn't going to work. It's not even. 3 and 15. 4 is not going to work. 5 and 9. 6 does not go into 45. Neither does 7 or 8. And 9 is already on my list. Now, once I have my list done, you're looking for the largest number that appears in both lists. In this case, it was 15. So 30 and 45 have a GCF of 15. Now, we haven't done anything with it, and that's not taking the algebra into account. That's just showing you a reminder of how to find a GCF. Now, let's talk about the algebra. For variables, it's a little bit different. Let's talk about what our powers mean on our variable. Let's say we have x to the 5th and x to the 3rd. Well, x to the 5th is really 1, 2, 3, 4, 5 x's multiplied together. X to the 3rd is 1, 2, 3 x's multiplied together. What do they have in common? 3 x's. So when dealing with variables, you're looking for the smallest power of the shared variable. Okay? Now, obviously, I could write it out and circle how many are in common, and that's great, but if I have a big number, I really don't want to do that. Now, sometimes you'll have more than one variable at a time. So let's say we have x to the 5th, y squared, comma, and x to the 9th, y to the 7th. So first thing I check is that both of the terms already have both variables. So do they both have an x? They do. So when I look at the x, which is the smaller of the powers for that shared variable? 5. Do they both have a y? They do. Which variable has the smaller power? Y squared. This is my GCF. Okay? Now let's get into what this video was actually designed for, which is factoring a GCF from a polynomial. So sometimes your polynomial has no GCF whatsoever, and in that case, you would write prime because you can't pull a GCF out of it, and it doesn't, well, you have to check the other factoring methods that come later too, but if you cannot factor it out any, it's prime. The one we're going to start with today, very simple, 6x plus 3. I recommend that you pause the video here and try it out, but what do they have in common? They both have 6 and 3 have a 3 in common, and I have an x here, but I do not have an x here. So I can't use x because it's not a shared term. So if everything has a 3 in common, then I'm going to divide by 3 on both sides of this plus. The 3 is a GCF. It does not disappear. This is not magic. Okay? The 3 is a GCF that has to stay out front. Think of it as undistributing. We're taking the 3 back out. We're dividing the 3 out like a GCF. So if I wanted to check when I'm done, I could distribute it back in and see if it works. 6x divided by 3 is 2x plus A lot of people cancel this 3 over 3 out and leave it off, but what is 3 divided by 3? It's 1. It doesn't disappear. 1 is a number. This is the answer with the GCF factored out. Another one. Let's go with 24x squared minus 8x. When I look at 24 and 8, their GCF is 8. Anytime one of your numbers goes into the other one, that's the GCF, because it's the biggest number you can do. All right, x squared and x to the 1. X to the 1 is going to win out. So my GCF is 8x to the 1, which is just 8x. When I take my GCF out, 24 divided by 8 is 3. X squared over x to the 1 is x. Minus, when I divide something by itself, it leaves a 1. Okay? Just a couple more of these to give you a really good idea of what's going on. Let's look at number, oh, we're not numbering these. 2x to the third minus 3x squared plus 5x. Again, I highly recommend that you pause the video on each of these and try it out before I do the answer. 2, 3, and 5. 2, 3, and 5 only have one common factor, and it's a 1. You're not going to use a 1 as your GCF because it's not going to change your numbers at all when you divide by it. So there is no numerical GCF here that we're going to use. I have x to the third, x to the second, and x to the 1. Since they all have x, we use the smallest power of the shared variable, which is x to the 1. The GCF sits out front. Here, 2x squared, because 3 minus 1 is 2, minus 3x, because 2 minus 1 is 1, plus 5, because the x's cancel. I can leave the x's off because there's still something there. The 5 is still there. Technically, it's 5 times 1 is 5. And that is how we factor out our GCF. Let's get one more that's a little bit more challenging. 18 m squared n to the fourth minus 12m squared n to the third plus 24 mn squared. So we need to start with our 18, 12, and 24. And yes, I know a lot of you have already got that figured out. Biggest number that goes into all of them would be 6. M squared, m to the 1. So my GCF, sorry about that, is going to be 6 with an m, into the 4, into the 3, into the 2, n 2. So when I divide by 6m n 2, or n squared, I'm sorry, that's the correct terminology, in all three of these, 18 divided by 6 is 3, m squared over m is m, n to the fourth over n squared is n squared, minus 12 over 6 is 2, m n, plus 24 over 6 is 4, m and n squared both cancel, and that's it. Good luck with the GCFs, guys.